Hi there everyone, welcome to the episode number 4 of this video tutorial series on academic illustrations. In today's episode, we will look into Python and learn how to create these kinds of line plots using this programming language. In the last episode, we actually looked at Matlab and did sort of similar operations, but Matlab is a paid software, and so I think a tutorial on Python would be appreciated by everyone who can't get access to Matlab. So Python is actually freely available for anybody to download for Windows, Mac, Linux, for any operating system. And so this is probably the biggest advantage of using Python. It is being actively developed. It has a good solid documentation. The user base is very friendly. And so definitely if you choose Python, you are future-proof for anything that you want to do with your research projects. Right. I think another big advantage of Python is that it is very wide-ranged, I can say. It is very general, so you can customize it according to your liking. You can do mathematical analysis, plottings, you can do all sorts of stuff. So you can develop artificial intelligence with it, and it is very popular right now for a lot of stuff. Also, this generalization is one of the disadvantages of Python, I think, because it is so general, it is not exactly easy, I would say, not very easy to read files or create line graphs or charts with it. You need to import a lot of modules, external modules. You need to install those modules after installing Python, and so that is probably a little bit disadvantage. So yeah, that was the good and bad points of Python in brief. If you are interested, please head over here and read about all the beginner's guide on Python, and you can check out other resources as well. All the links will be down in the video description. So for today's examples, we will need to install Matplotlib and SciPy, these two external modules, and the installation instructions are given on this website. So you can just write this command in your command prompt, and it should be automatically installed by pip, the package management system of Python. After you have those installed, we can actually start coding. So this is our example 0. To save time, I actually wrote down a few examples already. All the template files, these example files, will be available for download in the video description. So please don't worry about pausing the videos and typing it yourself. Just follow this video tutorial until the end, as always, and hopefully you will understand enough to write it by yourself. Alright, so as you can see over here, I am just taking my dependent variable and independent variable of x and y. The y values I have written down 21 points, just random data set. Over here I am using np.linspace to create 21 data points from -1 to 1. Now this np is actually an instance, the name of NumPy, the module. This is why you need to install SciPy. From SciPy, we will also get NumPy as a sister package inside SciPy. So after that, we can import NumPy as np, and then np has this function inside it, linspace. And we also need to import pyplot, and this is the name that I'm using inside this namescape. For me, it is Plt. So Plt has this function of plot. I'm calling this function with x and y, and I'm specifying that the line width should be 2. And also I am giving this x label and y label. Okay. All right. So up to this point, it looks like this is okay. If I hit run, let's see what happens. We can see that over here in the Python shell, it actually completed running the code, but unfortunately we can't see anything because we didn't actually tell Python to actually show the plot that it created. That is why we need to uncomment this one, this plt.show command, and now if we run again, okay, we can see that Python is actually showing us the graph. All right, so from here you can actually save the graph as a figure, but again, like we described last time, doing this every single time is not a very time efficient process, and so we would like to do this inside the code. Fortunately, Plt pyplot also gives us this function of save figure. So if we uncomment this one, we can see that we can give this function a parameter. This is the name of the file, so it has the extension already over here. We want it in PNG format, and this is the bounding box, and I want it to be tight. So the bounding box will not have any external margins around it. Alright, up to this point I think it is not very difficult. So if we run the module one more time, close this one, and let's see, we can see that it already gave us the output, but this is very low resolution, so we will have to fix that one. Maybe we can check out example 1 and slowly progress our way towards creating high resolution image. So in example 1, we will actually deal with reading external data files. For that, first we have to import the CSV module at the beginning of our code because it is not by default included. After importing that one, we can actually use the csv.reader function. This line over here is a recommended way of using external data files because we want to open data files, do some kind of operation, and then close it as soon as we are done with it. So this command with open and as data file, this will help us deal with that problem easily because Python will take care of it for us. We don't need to use file open and file close commands like other programming languages. Okay, so you can see that I have given it this name of my external data file, that is l18.iv. I gave it this parameter of r because I want it only as a readable file. I do not want to write it. And over here, I gave this function, this parameter of delimiter, to be \t for tab, because when I opened it using this text editor, I'm using idle that was included with my Python installation. When I opened it, I found out that this is recognized as a tab, not a spacebar, but as a tab. So I gave this delimiter to be \t. So this will actually read the file for me, but there is one simple problem, that my file actually has 4 lines of header information. So these are not data values, I do not need those. That is why this small chunk of code over here will actually ignore the first 4 lines. You can change this value to actually increase or decrease the lines of headers in your own research data. Okay, so after that, I have to create empty spaces for the x and y values that I'm going to get from the file. So I'm creating those 2 arrays. And now this is the for loop technique in Python. For each line in content, this is the content that I have just read from the external file. For each line, please append the floating point value of line 0 into x, and please append all the floating point values of line 1 into y. If I don't convert to floating point values, then this is actually read as a character, and so x and y will be something like an array of characters, so we will not be able to plot it. That is why we need to modify the characters. We need to transform them into floating point values and then append them into x and y. So up to this point, from here to here, is actually reading all the data and getting x and y. After that, this part is exactly the same as example 0. So this is the way we need to read external data files. Now if we run this module, we can actually see that Python actually read the external data file and gave us this plot, which is pretty good. The reason why Python actually printed out all the values, because I actually wrote down print command over here, this print function. If I comment it out and hit F5, hit OK, then you can see that Python runs and then it doesn't show me all the values. but this is sometimes useful for debugging purposes, so this is over here. All right, so it looks okay. I closed the figure, so it looks pretty okay, but still we want to make this axis much better, and maybe we want to control the tick values, the x and y limits, and that is why we can actually check out further examples, maybe example 2, to see what we can do about that. So in example 2, there aren't so many differences compared to example 1, but there is this application of Plt Style. So Pyplot actually has a few default styles that are built in. The styles are actually shown over here in their style sheet reference. So you can see that there are dark themed and grayscale themed image styles, plot styles. So if you find one of them useful for you, you can just take this name, for example seaborn-muted or seaborn-ticks that I'm using in this example. If you write this one, then Pyplot will apply those style options into your image for you. After I have included this one, I just mentioned the Y scale to be linear. I think this one should be X scale, so I made a mistake, sorry. So I mentioned the X scale and Y scale to be linear. I have also limited the X axis to be in between -6 to 4. With all of these modifications, if I run the code, let's see how it looks like. So you can see that Python actually applied larger tick marks over here for us. It also changed the font family, but unfortunately still the font size is too small. So we would like to modify it and make this style according to our own liking. And that we have done in the example 3. This is the last example for today. As you can see, there are 3 new lines over here. I am just updating the parameters of Plt, the font size parameter to be 18 and the font family parameter to be Arial. And I am also importing the submodule of figure, and I am changing the DPI parameter to be 300. I am changing the figure size to be 5 units along the x-axis and 4 units along the y-axis. I am also changing the face color, the background, to be white and the foreground to be black. If you have followed the previous episode, I think you will notice that many of these syntax look very similar with MATLAB syntax. That is why I mentioned at that time that you just need to get accustomed to one single programming language, and you will find it much easier to transition to another programming language if needed. That is why after you have this idea that what to do if you need to modify some style options, you can actually apply that knowledge to many other programming languages. We are very lucky that this Matplotlib actually works very similar to MATLAB. So these two programming languages are pretty similar in their syntax, but this actually applies to all other programming languages as well. Alright, with that said, just by adding these 3 lines, we can actually run the module and see what happens. This image is just too large because of the DPI. Let's close it and see the output for ourselves. This was the output of example 2. As you can see, it's quite small and the axis labels are just not visible. It's just too difficult to see. This is our output right now. This is the output 3. As you can see, this is Arial 18 points. This is the line graph, and there are some circles around it. This one did not have the circular markers. So let me describe that one as well. The markers are here because of this line. So after plotting the line graph with line width of 2, I plotted one more time only the data points. So the data points were over here. They were plotted using a cyan color with an alpha value of 0.6. Alpha is the level of transparency, and that is why you will see that the output has slightly semi-transparent markers like this. So that one is because of this extra line. And what did I do extra? I didn't do anything else. So this is the x limit and y limit over here, And these are the tick values. I don't really need them right now. That is why I commented them out. I can show you guys some basic ideas on how to actually do some mathematical operations. And I think that way we can finish this tutorial over here. In the previous episode, I showed this example that how to actually change the values into absolute value and then change the scale of the y-axis. I think I will show similar example over here. So because we have our data in the x and y array, we can actually just do some operations over here or create a new function to actually write those operations. It depends on you what you want to do. For me, I think I can modify the floating point values to be absolute values just by writing this one. And I can change the y scale to be logarithmic like this. Now, if I run the module, I will see that the plot has been modified and now the output looks like this. So this is applicable for output of a photo detector, for example. So this one, I can see that the upper limit is not visible properly. So this is where I can actually take advantage of the y limit like this. So if I uncomment this value and hit run, I think the output will look much better. So close this one. And now we can see that there is an upper value and a lower value. So it looks much professional, much more professional. Okay. So right now we didn't do anything like super fancy, but if you want to find different frequency components of your research data, you can do Fourier transform on Y. If you want to do some other kind of mathematical analysis, if you want to find the mean square error or a standard deviation, then you can find that just by using these values after reading your external data file. So this is the basic idea on how to actually read data files and get that data to plot graphs in Python. Only these three lines are just dealing with the style and the export of the image, and this line is actually just saving that figure as a PNG image. If you have any questions or any suggestions, please let me know. All the links showed in this video and all the template files shown in this video are also linked below in the description, so please check them out if needed. Alright, I think that's about it for this episode. Thank you very much for joining me. See you guys next time.